Hello everyone, hopefully you're doing well. In this video, we're going to start with chapter 3, describing, exploring, and comparing data. Usually nowadays, we get results not only by memorizing formulas or manually doing a lot of exercises. We can just get results with a calculator or software that we can focus on making practical sense of results through critical thinking. So we can use Excel, we can use our calculator TI-84, we can use StatCrunch, there are so many tabs, there are so many different software we can use to to analyze and describe data, right? So, because the methods we present usually in this chapter, it would be about descriptive statistics. Remember, we said for the the statistics, the science of study, the science of collecting, summarizing, displaying data, we call it statistics. So we have the descriptive branch of statistics that we talked about on the first chapter, and we have inferential statistics that we would have a chance to talk about later because the descriptive statistics, they summarize or describe relevant characteristics of data. But to make inference about a population, we use inferential statistics later. But in this particular chapter, let's focus on measures of center. So in this chapter, what we're gonna do, and in this section, what we're going to do, we will develop the ability to measure the center of data by finding the mean, median, mode, and mid-range. We will determine whether an outlier has a substantial effect on the mean and median. Okay, and later we'll talk about measures of variations and measures, measure of variation and measure of positions. The key concepts, the focus of this section is to obtain a value that measures the center of the data set. In particular, we present measures of center, including mean, median, and all right. Our objective is not only to find a value of each measure of the center, but also to interpret those values. Okay, so we'll try to include core concept that should be understood. Okay, so let's see for measures of the center. So a measures of center is a value that represent a typically or central data entry of a data set. So a measures of the center is a value at the center middle of a data, right? So measures at the center. So we said the measures of the at the center. We have the mean, okay? The three most common used measures of central tendency or measure of the center, mean, median, and mode. Let's go for the mean. If you have a data set, the mean or arithmetic mean of a data set is the measures of center found by adding the number of data, right? So usually, let's say if you have a data set like 2, 5, 1, 6, 7, 3, 2. All right, let's have this data set. So for us, I'm gonna write bigger than that. So we said it's a 2, 5, 1, 6, 7, 3, 2. All right, so if you have a data set like this, right? If you have a data set like this one, if they ask you to find the mean, if they ask you to find the mean of the data, so the first thing to do is really to add them all. So the mean for us, the mean is like the average. You need to add all the data you have up here. Okay, if you add them all the data, then you divide by the number of data. 1, 2, 3, 4, 5, 6, 7. So here you see n is 7. The number of data is 7. So all you need to do, You need to add all the data. 2 plus 5, 7 plus 1, 8 plus 6, 14 plus 7, 21 plus 3, 24 plus 2, 26. So we have 26 over 7. So if you have 26 divided by 7, okay, so it gives you 3.71. So this is the mean. So for us, that's how you're going to compute the mean. Anytime they ask you to compute the mean, you add up all your data together and you divide it by the number of data. So quotients never use the term average when referring to measures of center. The word average is often used for the mean, but it is sometimes used for other measures of center. So the term average is not used by statisticians. The term average is not used by the statistics community or professionals. Now, of course, let's say when you go to an office and apply for healthcare, for example, healthcare benefits, they would ask you what is your average income. Mean, sometimes people say, oh, mean is equivalent to average. So it's about concept, the linguistic parts of this. So the average, what is your average income? Okay, so you add up, you take a few paychecks, maybe you take four different paychecks, you add up all, you add up all the and pays, your salary from each paycheck. If you have four of them, you add up for all four and you divide by the number of paycheck, which is four. So important properties of the mean. Sample means drawn from the sample population tend to vary less than other measures of the center. Remember, sample mean, if you have any outlier, the measures of a data set use every data value. So that's the disadvantage because let's suppose you want to know the average salary in a company. You can add all the employees annual salary and divide by the number of employees. But the problem, what if most of employees get paid between 50,000 to 60,000 dollars annually, but there are one or two employees that get paid 300,000. So if you have two employees get paid, and maybe the CEO or the research and development officer, so if they get paid a lot of money, okay, if they get paid a lot of money, then that would affect everything. So the disadvantage of the mean is that just one extreme value that we call outlier can change the value of the substantially, of the mean substantially. So let's say for example, if you have a lot of data, I'm gonna pick up the same data I had here. Let's say I take this data set. Let's suppose I have this data set right there. I'm going to put it here. Okay. This is my data set. Now, if for some reasons I have one more data in this one that will say, for example, 19, right? So you see from that data set where n now is 8, I have 8 data, right? So 19 means it is pretty far from all because before 19, the largest one is 7. So you see the difference between 9 and 19. Now, if I add all these data together, look at the mean. Remember, this would be 26. Okay, so that would be 20, that would be 26. Okay, that would be 20. The mean in this case, when you add all of this, that would be 2 plus 5 plus 1 plus 6 plus 7 plus 3 plus 2 plus 19, and divided by 8. Now, see, the top part would be 26 plus 19. That gives you 45 over 8 divided by 8. Okay. The the average would be 5.6025. So that would be the mean. Look at the previous mean. What the previous mean says, it's only 3.71. Now the new average would be 5.62. It's almost double. So that's a big problem when you have it this way because the mean the mean is totally different, right? So make sure the mean is totally different, okay? So what you need to do is really get the mean, okay? So and it will be different. Now let's see for resistant. A statistics is resistant if the presence of extreme values, outliers, does not cause it to change very much. So we call it, we said it's resistant, right? All right. Now, this is the formula on how to find a mean. You know, if you deal with a population or a sample, there are two different ways. Let's suppose it was a population. Population for population and sample. If it's population, the mean, we're gonna call it mu. That's a symbol. Symbol for the mean, if it's population, you will call it mu. So symbols, we call it mu. It's a capital Greek letter mu. And for sample, we're gonna call it X bar. So X bar for sample. So that's how we're gonna call the mean. So as you can see, the mean, it can be either the mu, which is sum of all xi over capital N, or x bar equals sum of all xi over small n. And remember, n is the sample size, or capital N is the members of the population, is population. Okay, sample size, population size. Okay, so if the data are a sample from a population, the mean is denoted by X bar. If the data are the entire population, the mean is denoted by mu. So the lowercase Greek mu. We usually use the summation. Let's say mu equals summation of xi over capital N. All right, so remember we said this is summation. X is the variable usually used to represent the individual data values. N is this represent the number of data, is represent the number of data values in a sample. And we have capital N represent the number of data values in a population. So that's very important. Okay, so that's very important. So you need to make sure you follow this one. These are the formulas. X bar is pronounced X bar and is the mean of a set of sample values. Mu X bar, mu, okay, is pronounced, is lowercase Greek case letter, is the mean of all values in a population. So these two formulas, I would advise you to put them somewhere, okay? Very important. You need to put them somewhere to make sure it's working. The median, okay, the median of our data set, let's see, let's take the same example. This is the median. So we're gonna consider, remember I show you how to find the mean. If you have the same data set, let's suppose we have 7 data here. The median is the data of a data set is the measures, is the measures of center that is the middle value when the original data values are arranged in order or in increasing or decreasing magnitude. So you need to reorder your data, put the smallest one first. Let's say I see 1 as the smallest one. I'm gonna cancel it. I see 2 twice, 2, 2. Yep, I cancel. I see a 3. I see a 5. I see a 6 and a 7. So this is our data set, our new data set. So you see this data set right there. You know, we order it from the smallest to the largest. So what happened if they ask us to find the median is the data that's fall exactly in the middle. The data that's fall exactly in the middle in ordered data set. Now, which data fall exactly in the middle after we order it from the smallest? We arrange our data set from the smallest to the largest. Well, actually, it's this one. It's 3. Okay. So what we need to do, as you can see so far, the data that fall exactly in the middle is 3. So the median is 3. If the data set, right, is not ordered from the smallest to the largest, or if the data set, let's suppose we have a data set that has um in even numbers, because here the number of data in that data set is 7. Because the number of that data in that data set is 7, so we take exactly the one in the middle. But if it was an even number of data, let's suppose if the data set was let's put the 19 in. So we had like 2, 5, 1, 6, 7, 3, 2, 19, as we did before. Let's reorder it. If we reorder it, it would be 1, 2, 2, 3, 5, 6, 7, 19. Now, what would be the mean? The mean would be the data that's all the mean of the middle. So because the mean should be right here where you split your data half, so you need to take the mean of these two data. So mean and sorry, the median would be the mean of the middle. So 3 plus 5 divided by 2. Let's make it 8 divided by 2. So the median would be 4. Even though you don't see 4, that would be 4. So if the number of data is odd, you take exactly what's fall in the middle. If the number of data is even, so you take the mean of the middle. Okay? So the median does not change by large amounts when we include just a few extreme values. So the median is a resistant measure of centers, and the median does not directly use every data values, So it doesn't matter you have a big number like 19. It doesn't affect it. We only pay attention uh, to the data that's fall exactly in the middle. It's not like the mean take into account all the data in the data set. Remember, the mean is very different at that point. We said the median does not change by large numbers, as we said. All right. Calculation and notation of the median, usually we call it M, so the median of a sample is sometimes denoted like X, all right? X tiled, like this, okay? Or M, we can put it M capital, or we can say just the median. To find the median, first sort the values, arrange them in order, and then follow one of these two procedures. If the number of data values is odd, the median is the number located in the exact middle of the sorted list. If the number of data values is even, the median is found by computing the mean of the two middle numbers in the sorted data. So very important to verify this. So how about the mode? The mode, again, the mode of a data set is the value that occurs with the greatest frequency. So the data that is repeated the most. Let's suppose we take the same data set I just gave you. Okay, let's do it. This is our data set. You can order it from the smallest to the largest, or you just pay attention which data is repeated the most. Now, I know if I reorder it will be 1, 2, 2, 3, 5, 6, and 7. So what data is repeated the most here? The one with the largest frequency, the greatest frequency. What is the mode? Yes, the mode is 2, because the data that is repeated with the data with the highest frequency. So what you need to see so far, what I did with that data set, as you can see, in order for me, I'm gonna just include this in your slide. Let me include this slide. I'm gonna just, okay. So you see with such a small data set, what we did, if I said for this for the data set above, find the mean, median, and mode. Okay, find the mean, median, and mode. So remember for A, we find the mean, we don't say what it is. We add all our data together and we divide it by n. So which is, remember what we do? We do 2 plus 5 plus 1 plus 6 plus 7 plus 3 plus 2 over 7 because we had 7 data. Remember, what did we find again? When we add it was 26 over 7. Remember, do you remember what did we find when we divided 26 by 7? It gave us 3.71. Now, when we find the median, because the data set is odd, you need to reorder it first. So we need to do 1, 2, 2, 3, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. We have this data set. So for us, the median was the data that was exactly in the middle after you ordered the data from the smallest to the largest. So for us, median is the data that's all exactly in the middle is 3. Now, the third question, find the mode. Remember, the mode is the data with the highest frequency. What is the data that is repeated the most from that data is 2. So these 3 informations, we call them measures of central tendency. So of course, each of them has their own particularity. All right. Remember, for the mode of a data set, the mode can be found with qualitative data. Okay. A data set can have no mode or one mode or multi modes because we might have not only 2 repeated twice, maybe 3 or 5 could be repeated twice. Now, for a data set can have one mode or more than one mode or no mode. When 2 data values occurred with the same greatest frequency, each one is a mode, and the data set is said to be bimodal. Okay, very important to pay attention to that. When more than 2 data values occurred with the same greatest frequency, each is a mode and the data set is said to be multimodal. Okay, when no values is repeated more than once, we say there is no mode because, if the data hasn't been repeated more than once, we said there is no mode. All right, so very important to verify all of this. Some data set have all of them. Another measures of center, we call it mid-range. The mid-range of a data is the measures of center that is the value midway between the maximum and the minimum values in this original data set. So how do you find it? It is found by adding the maximum data and to the minimum data and then divide the sum by 2. All right. Let's suppose we have a data set like this. I'm going to take where we order it from the smallest to the largest. So let's take this one. If I consider this data set, let's do this one. Okay. As an example, if we have this data set already organized, remember the mid-range for us, the minimum here, the smallest data is 1 and the largest data is data here is 7. Now, if I want to find the mid-range, because the range in itself, range of the data, probably something we covered in the previous chapter, is the maximum minus the minimum. So that's range. So that means the range would be 7 minus 1 is 6. But if we talk about mid-range, mid-range would be the maximum minus the minimum over 2. You divide by 2. So that means 7 minus 1 divided by 2 is give you 6 divided by 2 is 3. Okay, so that's how you find your mid-range. important facts about the properties about the mid-range. Because the mid-range use only maximum and minimum values, it's very sensitive to those extremes. So the mid-range is not really resistant, right? In practice, the mid-range is rarely used, but it has three redeeming features. So many books, like the previous textbooks I used, they never ask us to in that book to find the mid-range because we don't use it very often. But the mid-range is very easy to compute. The mid-range helps reinforce the very important point that there are several different ways to define the center of a data. Uh, and the values of the mid-range is sometimes used incorrectly for the median, which is not true. Okay, it's not true. So confusion can be reduced by clearly defining the mid-range along with the median. So remember, mid-range, median is two different things because the median, there is no computation. The only thing you do with for the median is to reorder the data from the smallest to the largest and perform it. Now, looking at these data sets, what they ask you to find the mean, median, mode, range. And if there is any extra questions, you need to answer that question. So let's see for this data set, remember, I'm gonna do these examples manually. Then we will, in a different video, please follow for my Excel file. Look for my Excel file where I would add all these videos covering on how to compute those using technology. Especially, we're going to use Excel. So, list below are the jerseys numbers of the 11 offensive players on the starting roster of the New England Patriots when they won Super Bowl. What do the results tell you? Right? First of all, we're going to answer these questions. What do the results tell you at the end? For now, let's focus on the question to find the mean. All you need to do how to find the mean, make sure you add up all these data together. So if we're looking for the mean, okay, so the mean here, because it said list out just it says very simple. It says simple. So we call it X bar. X bar sum of all X. Add all the data you have in this data set. You add all the data you have in the data set, like you do 12 plus 26 plus 46 plus 15 plus 11 plus 87 plus 77 plus 62 plus 60 plus 69 plus 61 and count the number of data you have in that data set. What are the number of data you have in the data set? When you count them all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you see n is 11. So we divide by 11. So for us, the mean X bar would be anything when you add up all this data together that I don't need to do. But I know when you divide by 11, the final answer would be 47.8. Okay, so this is the answer for the mean. Okay, they ask you also to find the median. For the median, in order to find the median, you must reorder the data from the smallest to the largest. To find the median, you need to reorder the data. Let's reorder the data, reorder the data. I'm going to try to do it with a different. So, what's the smallest data you see in that data set? The smallest data, I believe, is 11. I see 12. 11, 12. I see 15. I see 15. And what else after 15? No more. We see 26, right? After 26, we see 46. You must reorder data, otherwise you cannot find the median. 60, 61, 60, 61, 62. I cross them out so I don't take them twice, or it make it much easier for me. I see 69, 77, and 87. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what data fall exactly in the middle because this data set is odd. The number of data odd data because it's 11. Remember, it's really 11. So what we need to do is reorder our data. So we ordered 1, 2, 3, 4, 5. So this is the data that's fall exactly in the middle. That would be our median. All right. So because if you count on the left of 60, you find 1, 2, 3, 4, 5. You count on the right of 60, 1, 2, 3, 4, 5. So the median is really 60. Okay. Now the other questions is C. They ask you to find the mode. The mode is the data that is repeated the most. Do you see any data that is repeated more than once? In that data set, there is no mode because no data is repeated more than once, so no mode. Okay. Now, C, D, they ask you to find the mid-range. So remember the mid-range is you need to take the maximum minus the minimum divide by 2. What's the maximum in that data set? You can see it. Max is 87. Mean is 11. So we have 87 minus 11 over 2. Okay, taking this mid-range, mid-range would be 87 minus 11 divided by 2. So you would see that the mid-range, oh no, sorry, plus. Do we said did I said minus? Because I believe the mid-range was a plus sign. I'm probably making a mistake in the previous section where I find the mid-range. Oh, I'm sorry for this because my mid-range was going to be 8 over 2, which is 4. Okay, mid-range is a plus sign, not a minus sign. So I made that mistake. Apologize for it. So it's gonna be 4. So here also in these examples, the mid-range would be plus 87. Let me say 87 plus 11. That would be 98 divided by 2. That is 49. Okay, so we have find the mean, we find the median, we find the mode, and we find the mid-range. But they ask you a questions after this. What do the results tell us? That is subjective. Everyone might express it the way they feel it is. But what I can say, looking at the results, you see the mean is 47, the mean is really 47. 0.8. The median is pretty far, but the mid-range is closer to the mean. Okay, so the resulting, we can say like the Jersey numbers are nominal data that are just replacements for numbers. They do not measure or count anything. So the result statistics are meaningless, right? So because we're talking about the jerseys, right? Those numbers doesn't mean it. The resulting statistics are meaningless because the jerseys number are nominal data. You cannot whether we do this just to practice the mean, median, and mode and mid-range, but it doesn't mean anything to us, right? Because we're talking about the Jersey's numbers, right? Jersey's numbers is only tells you sometimes which positions a certain player are on which positions they are on the pitch. Because let's say if you real football, right? European football, the real football, you have the strikers, you have the defenders, you have the mid defenders, more defensive or defenders, right? And the keeper, right? The goalkeeper, the goalie. So the numbers tell us something. Someone with a number 1 more likely to be a goalie. Someone with a number 9 is more likely to be a striker, right? So that's how we do it. Now, right, and examples, I believe this one also is 11 data. I usually do one examples and leave the other ones for you. Please follow the first examples to do this one on your own. If we look at that one, here it's a bigger data set, right? So this data set, as you can see, right, very important. If you consider this data set, the first thing to do to find the mean, I believe, let me do this one smaller. Maybe I need space. I don't wanna, I'm gonna put it 14. I'm hoping you can, let's put it that way. So I have enough space for it, right? Okay. Now, in this data set, what you can see, we find the mean, median, mode, and mid-range. And so the question, biologists conduct experiments to determine whether the deficiency of carbon dioxide in the soil affect the phenotypes of peas. Okay, listed below are the phenotype codes, where one smooth yellow, two smooth green, three wrinkled yellow, four wrinkled green. Can the measures of center be obtained for these values? Do the results make sense? So we can answer these two questions after. But let's answer the first questions. Find the mean. Remember, for find the mean, what we do again? Mean. Are we talking about a sample or yeah, it's definitely a sample. Remember, for the sample, you need to add every data you have in that data set and divide it by the number of data. First of all, count the number of data. I believe it would be 25. You're gonna find 25 data here in total. Now you add them all. Start with the 1 plus 1 plus 1 plus 1, but you need to go all the way to the last data, like 3, 2, 2 divided by the number of data, which is 25. You add them, take times to add up all these data and divide it by 25, and at the end, answer would be 1.9. All right? So remember, we have our mean x bar equal 1.9. Now, for the median, again, it's very important to reorder your data from the smallest to the largest. So what I'm gonna do again is reorder. The smallest data here, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm gonna have 11 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, how many twos I have? 1, 2, 3, 4, 5, 6, 7, right? I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now let's go with 3. With 3, 1, 2, 3, 4, 5, 6. 6, 3. 1, 2, 3, 4, 5, 6. You must, no matter how big your data set is, you must reorder the data from the smallest to the largest, right? And how many fours? So I feel like I see only 1 4. Now I just want to count and make sure I have really 25 data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now, the data that's all exactly in the middle is the median. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We know the data that's all exactly in the middle is the median. So for us, the median here is the data that's all exactly in the middle is 2. Now, we do the same for C. They ask you for the mode. What's the data that's count the most? As you can see, we have many ones, many twos, but ones is the one that's count the most. So we have 1 as our mode. The mode is 1. The mid-range, looking at this data, remember the minimum is 1, the maximum is 4. To find the mid-range, what we do, You take the maximum, you add it to the minimum because the maximum added to the minimum, and you divide by 2. So 5 divided by 2 is 2.5. Okay? That's how you answer these 3 questions. Now, we can answer the other ones because they said, oh, you know what? And answer the given questions. Can the measures of center be obtained of these values? Yes, you can, right? The measures of the centers, is that what we did? I believe that's exactly what we did. We found the measures of the centers, right? The mode of one correctly indicates that the smooth yellow peas occur more than any other phenotype. But the other measures of center don't make sense with these data at the nominal level measurements, right? So that's what you can say about this. It doesn't make sense for the other ones, but the mode tells us which one is repeated the most, okay? Other examples, because as I said, I do one, I let you do one. I do two, I let you do two. So I do different ones, and you answer the same type of questions for each of them. It doesn't matter, the questions would be the same. If we go here and ask you the same questions again, all I can do for number 5 is to, make it 14 too, so I will have more space. Let's do 16. And this data, as I said again, you find the mean. We add all the data, 74.4 plus 76.3 plus, until you get to the last one, which is 81.9, divided by the number of data. So we must count the number of data in that data set. Don't forget, you must count them, how many data you see in that data set. It is 20. So n here is 20. So we're going to divide by 20 when you count the number of data. So doing this, you would obtain, at some point, when you add everything and divide, it would give you 79.61. Okay, so that would be the mean. So mean X bar would be, it's really X bar, right? 79.61. That would be the mean. And do you remember how to find the median? Yes, for the median, you really need to reorder the data from the smallest to the largest and take the one exactly in the middle. Now, this is the problem with this data set. If you reorder the data from the smallest to the largest, oh, sorry, you must reorder it from the smallest to the largest. But how would you reorder it from the smallest to the largest when, in fact, most of our data here, you need to, is the number is even. So you need to reorder them. So we can either start identify what's the smallest, what is the minimum data. All right. Let's say everything in the 70s. We believe 74.4 is the smallest data, right? And what is the largest data is in the 82. It would be in the 82 because 82.5 would probably be the largest data maximum. 82.5. So if we order the data, first of all, make sure you start with 74.4, like the smallest one, okay? And you see you're gonna have 76 because there is no 75, 76.3, 76.4, all right? And we have 76.5, okay? We see 76.9, right? You see 77.4, 77.9, sorry, 0.9. We have 79.4, Do it 79.9 down here. So we're no longer in the 70s. We can take the 80s. 80.2, 80.2 twice, right? 80.2, 80.2. Let's take 80.2, 80.2. Now we have 80.4, 80.8, okay? 80.9, right? Do we have more 80s? No, we have 81.0. We have 81.1. We have 81.2. We have 81.9. That's the last one. Now we have 82.1, 82.2, and we have 82.5. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah. Now, when we have 20 datas like this, because we said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the median would be here. So you need to take these two because the data set is even. To find the median, you must add the two data false in the middle and divide it by 2. So what would that be? Because when you take the median 82.2 plus 84.4 divided by 2, it gives you 80.3 as the median. Okay, 80.3 as the median. Now, what is the mode? Mode is the data that is repeated the most. What is the data that is repeated more than once? More than once, we have 80. Which one repeated the most here? We can find it. I think 80.2. You see these two datas. So they are the one repeated the most, 80.2. Now the mid-range, we need to add the largest one to the smallest one and divide by 2. That gives you the mid-range. So what would be the mid-range when you add 82.5 plus 74.4? It gives you 78.45. Okay. Now you can answer the questions. They said, what extremely important characteristics of the data, what extremely important characteristics of the data is not considered when finding measures of the center? Different ways you can answer that one also. Okay. So you can say the data time series data, but the measures of center do not reveal anything about a trend consisting of a pattern or of change over time. That's one way you can answer, for these questions. Well, last one is looks the same. They ask you to do exactly the same. I would leave on the 6 for you, but let's do one of the number 7 very quick. The number 7 and 8 are the same. The only thing that's making them different is because you have two data sets. In these examples, what they ask you to do, because we must review when they ask us to compare data set, that's one of the things we can do when we have two data sets, how we can compare them. All right. In that data set, let's go, let me reduce it a little bit. I'm going to reduce because for this one, they ask you to find the mean and the median of each of these two samples, then compare them. Let's make it very small. Oh, let's do 16. We need space. Okay. Well, for the systolic, remember systolic, if we do this data set, because we try to do both of them, okay? Um, the systolic data set, let's do for the systolic. So remember the mean X bar, we need to add all the data 118 plus 128 plus until you get to 120. No, what is what is n? What's the number of data in that data set? When you put this together, we have 10 here. We have 10 data. When you add them all together like this one, because you add them all, it gives you divided by what again? We need to divide it by 10. So the mean of this data set, okay, for the systolic one is 127.6 millimeter gram. Okay. We now to find the median, you need to reorder your data from the smallest to the largest. Like we see the smallest one is 96, 116, 118, 120. Okay. 122, 126, 128, 136, 156, and 158. So I reorder my data from the smallest to the largest. So the median to me, because it's the number of data in the data set is even, right? Because it's 10, we need to take the two in the middle. 1, 2, 3, 4, 5. It should be here. So we're gonna take these two and divide by 2. So 122 plus 126 over 2. When you divide this by 2, it gives you 124.0 mmHg. So this is the median. They ask you to find the mean and the median for each sample, then we're going to compare. So this is what we find for the systolic one, right? So we do this for the systolic. How about we do it also for the diastolic? So I'm going to just change the color. Let's take I'm going to take blue. So we're going to do diastolic. Again, for this one, the mean would be X bar, where we're gonna add 80 plus 76 plus 74 until we get to the last one. We need to add all of them until the last one, which is 82. Again, what is n in this data set? N also is 10. So we're gonna divide by 10. Now we end up with the diastolic 173.6. 73.6 Hg. What could be the median? The median would be the data that's all exactly in the middle, but you need to reorder the data from the smallest to the largest. We see 52 comes first, 52, 58, 64, 72, 74, correct me if I'm wrong, 76, 80, 82, 88, and 90. 90 is the largest one. So we're gonna take the two in the middle. 1, 2, 3, 4, 5. So this is where you're gonna have the mean. So we add the two data in the middle and divide it by 2. What would be the median then? Median would be 75. Right? So we find the mean and the median. So all they ask you to do now is to compare. We must compare what we find. So in terms of comparisons, we see that given that systolic and diastolic blood pressure measures different characteristics, a comparison of the measures of center does not make sense again because the data are much, right? You know, it would make more sense to investigate whether there is an association or correlation between systolic blood pressure measurements and diastolic blood pressure measurements. So we'll have a chance to address correlation and regressions later, but that's how you can say. Remember, this answer is a little bit subjective that you can answer, all right, a little bit later, right after. All right. So in terms of I'll leave the other ones for you. You see round up rules for measurements of center for the mean, median, and mid-range carry one more decimal place than is present in the original set of values for the mode. Leave the values as is without rounding them because values of the mode are the same as some of the original numbers, right? So we can always calculate measures of center from a sample of numbers, but we should always think about whether it makes sense to do that. So we should also think about the sampling method used to collect the data. You see in this chapter, we talked about the calculation of mean from frequency distributions. Probably something I would let you to enjoy. I'll probably do one examples anyway, because first multiply each frequency and class midpoint, then add the product, something you can do, you know, and weight mean when different X values are assigned different ways, we can compute a way. So actually, one more examples that we can complete in this case because there are so many questions we can answer because what they ask you to do in this one is compute, you know, we can compute um, the mean of the data summarized in the frequency. Also, constant frequency distribution also compare the computed means to the actual means obtained by using the original list. So what they ask us to do, remember, we just use a formula to do that. So to use the formula as we just did, all right. So we need, first of all, we have the frequency. All you need to do, find the class midpoint. What is the class midpoint? You're gonna just add one more to this data set, right? What are the class midpoints? So remember, if you do seven, all you need to do, remember class midpoint. For example, in this first one, you take 70 plus 89 divided by 2. I'm going to just do the first one. Is 70 plus 89 divided by 2. It gives you 79.5. So we know the first one would be 79.5. You can continue again with the second one. 90 plus 109. 90 plus 109, you know, divided by 2, it would give you 99.5. 99.5. I'm gonna just put those lines because I need them just to continue, make sure we have all those lines. The midpoints always add the lower values. Remember the formula for the midpoint. Remember midpoint, lower class, lower limit, class limit, lower class limit, plus upper limit, class limit, divided by 2. That's the formula. That's how we find it. Now, if you know, I can simply 119.5 Okay. 139.5, 139.5, 159.5, 179.5, 199.5, 219.5. Remember, we see the width is 20. We simply add 20 each time. Now, the next one is to do the frequency F. Take the frequency F times X. Okay? So what is X at that point? Because you need to take the frequency, multiply by the midpoint. Okay? So that's exactly what you need to do here. You take the frequency, multiply by the midpoint. Let's say I'm gonna call this one X, okay? I'm gonna call the midpoint X. So I do the midpoint, the frequency times X. So for us in the third columns, what you need to do, make sure in the third column, for example, you do 79.5, okay? You do 79.5 times 4, okay? I don't really have all these one to do separately, but one thing you need to remember, you do 79.5 times 4, 99.5 times 7, 119.5 times 6, 139.5 times 6, 159.5 times 18, 179.5 times 5, 199.5 times 1, 219.5 times 3. So that's how we're gonna do it. Once you do everything, then you add, because for us, we are more interested to sum of F times X, which is the answer we're gonna find here. We need to find it. So whatever we find that I actually don't have, I can tell you exactly, because um, let's see. I'm gonna tell you what it is exactly. Um, um, let's do it. What is this sum? Because we need what is the sum of all these frequencies. Remember, we must add it. So if we have um 4 plus, no, let me do it. 4 plus 7 plus 12 plus 18 plus 6 plus 3. So I think this is 50. All right. So we find this one to be 50. Okay. So for us, and we need to know that sum. So, sorry. All right. I'm just checking my calculator. I believe this big giant sum would be 7,195. Now, once you find this answer, what they ask you how to answer the questions, as you can see, um, for mean from a frequency distribution, when you find the sum of the midpoint per time the frequency, you need to divide by the sum of the frequency. So for us, the mean, because they ask you compute the mean of the data, so that will be sum of the frequency times the midpoint over the sum of the frequency. So we say, no, the mean would be 7,195 over 50. So if we do 7,900 divided by 50, it gives you 143.9. That would be the mean of the frequency distributions, right? So which is close, kind of close, right? It is very close to the mean they give you. They give you 140.6, right? Uh, it's close to the mean 140.6 means obtained by using the original list of values. That's a long way anyway, but it's pretty close. Hopefully that's helped. We're gonna come back. I know it's a very long video, but come back for section 3.2, measures of variation, because in this section, in this chapter, we're going to see measures of the center, mean, median, and mode, measures of variation, range, variance, and standard deviation, and then later we'll see measures of positions, the quartiles, the 5 number summaries. Let me know if you have any questions. I'll see you in a different video. Take care.